Hello everyone, welcome to a new episode of Golang Cafe, and today we're going to talk about the http RoundTripper. So the http RoundTripper is a very interesting functionality of the Go standard library. And I have to say that because I've been working with a lot of different technologies in the past, and it's not been always so pleasant to work with HTTP clients and to write so very beautiful and idiomatic code with Go as it has not been with other languages I've been working in the past. So I just wanted to share with you the http RoundTripper and how it works and how you can improve your code by using it. So the first thing we're gonna do today, we're gonna run through a couple of very simple examples, so a couple of very simple HTTP requests, and then I wanted to show, where it fits and how it works, this http RoundTripper. The first step we're gonna do is go through the docs for the HTTP client. So most of you should be familiar with how you can create a HTTP request. It's a very basic operation. There's a couple of ways you can do that. For the most part, you use the http.Client. You create a new client and then you create a new request specifying your method and then your URI, and then you specify the body. In this case it's a nil body, so it's an empty body. Sometimes you can also use the http.get, which is a shorthand way to create HTTP requests. But today we're just going to use the HTTP client, which is the de facto standard for how you can create requests and Go. And if you go into the client struct, so whenever you create a new HTTP client for your requests, you create a client struct, and by default it's all instantiated. You don't need to worry about any of the fields. And some of the times, as you see here, you can specify the timeout for requests. I think we have seen this in one of the previous episodes on how you can control the timeouts for your requests. And then there is the most important part of the HTTP client, which is the transport field. The transport field it's basically an implementation of the RoundTripper interface, which is what we're gonna cover today. And it's basically just the way on how the HTTP requests are made. So it's a high level, it's kind of the highest level wrapper you can think of for the Go request response lifecycle. So the Go request response lifecycle can be represented as a round trip, as you can imagine here. So let's see what this round trip looks like. So the RoundTripper interface, it is a very small interface, as you may know, and as you may know from the other interfaces in Go. Most interfaces are very small. Most of the times, just one method. So they always try to keep the interfaces small. So it's always easy to have decoupling and have orthogonality in the language and composition across different types of modules. And the RoundTripper interface, it is what the central piece of the HTTP client, and it is a simple method with the request object and the response object and an error. So it is basically executing a single HTTP transaction, returning a response for the provided request. So it is it is basically kind of a lower level way of thinking about your HTTP client, but it's one of the highest level abstraction that you have. If you want to go deeper into how the HTTP client works, it's one of the highest level abstractions because it represents an entire single HTTP transaction. So it represents the HTTP transaction from the request to the response. And you can customize the RoundTripper, and that's the whole point of of the RoundTripper, and the fact that you can customize it, and the fact that you can do a lot of things with it. Obviously, the default one, when you create a new HTTP client, so if you go here and you create a new HTTP client, by default the RoundTripper is the default transport, as you can see here as well, which you can describe here. Transport doc http default transport. So the default transport is an implementation of RoundTripper, and as you can see here, you have a bunch of different variables and flags, which you're not going to see today. But you just need to know that, you know, this is just an implementation of RoundTripper. Today we're going to implement our own RoundTrippers, and we're going to see when it's used and why it's useful. Here is a couple of examples. So for instance, you have when you want to add logging to your request responses, it's a way, you know, it is a way. There's many ways of adding logging, but this is one of the ways. You can use the RoundTripper. You can define your own RoundTripper, and the RoundTripper can basically log your requests and response if you want. It can be used for retrying, so you can create a RoundTripper that will take care of retrying your requests when they fail, or whenever you see fit. So whenever you think they should be retried, or if you have some custom logic around your requests, then you can use a RoundTripper, a custom RoundTripper. If you want to have a pre-auth on your requests, so for example, if you have some requests and you want to build your code in a way that you want to create authentication, you want to manage authentication in a more elegant way, that you can use the RoundTripper as well. You can cache your requests as well, and you can manipulate your headers, and you can also use the RoundTripper for testing. For example, when you have to inject HTTP client into your methods, and you don't necessarily have all the interfaces in place, you can use a RoundTripper. You can use a fake RoundTripper to allow your tests to run. Today we're gonna try to see the first couple of examples, maybe the first three. We'll see how it goes, how we get there. So let's get started with the login one. So here I have a basic example from http.bin.org. It's just a simple request, and it reads all the response, and it prints the status code as well. So let's just see how it runs. So as you can see, it's pretty slow as well. So it is basically returning the status code and the response as a JSON. So the first thing we want to do is that we want to log each request, and we want to do that automatically by using a custom RoundTripper. So the first thing we will do, we define a struct logging RoundTripper that contains default RoundTripper, let's call it next RoundTripper, and then contains the logger, which is in this case just an IO writer. And as you can remember from the logging RoundTripper, from the interface, the RoundTrip is just a RoundTripper implementation. It's just HTTP request, and then it returns the HTTP response and an error. And then we have the next RoundTripper, RoundTrip. I'm going to explain in a second what this means. So basically, here we can log our message and info and all of that. So we first want to create the transport. So the transport is the actual field in which you set the RoundTripper on. So the first thing you do is you create the RoundTripper here, and then the next RoundTripper, which is the one that you're gonna use to execute the actual request, is gonna be the default one, default transport. and then the logger. So in this case, we just log to standard output. We import a bunch of stuff, and then we know that as we've seen in the http.Client .transport .client.transport, we have the RoundTripper. So here is where we want to set our new RoundTripper, and the RoundTripper is used, as I said again, is used as a wrapper. In this case, it is a wrapper on top of the default RoundTripper. So with this wrapper, we can basically intercept all the requests that we make, and then we can, as we like, we can log them. And how do we do that? So we just create the login RoundTripper, we implement the interface receives the requests, so this will intercept all the requests that we make through using the client that uses this RoundTripper, will intercept all the requests we made using that client, and then we send all those requests down the line into the default now RoundTripper, which is the next one. We call it next. But this, you know, we can call it default RoundTripper. Default RoundTripper. And then we can do the same here. Default RoundTripper. Obviously, we need to update here as well, which is next. Default RoundTripper. It's just to let you, to make you understand a little bit better what's going on here. So we're just using the default RoundTripper here, because you still need the default RoundTripper, which is the one that's sending the data through the wire, which is the one that's sending the network request. But you're creating a wrapper on top of it, and you are using exactly the same interface. So this is a very simple example of the decorator pattern. So one of the very well-known design patterns is the decorator pattern. So round trip is a decorator on top of the default RoundTripper. So it's using the decorator pattern, which is basically a behavioral pattern to extend the functionality of an object or a method, maintaining the same interface. So it maintains the same interface, but it changes or enriches the behavior of the same object. So in this case, we just want to print into our logger, and we use here we want to print the timestamp, and maybe we want to print the method and the URI. So the timestamp is time.now, and format time. We have to see the actual Golang time.format. Yeah, there are some layouts that you can use, so it gets already formatted in the way you want. So we have the time, and then we have the request method, and then the URL.string, and then maybe we want to print a new line as well. Yeah, I think this is a very bare, very simple version of our logger. Let's see if it works. Obviously, we'll need to import some of this stuff here as well. And let's see if I have everything standard out. I think I have everything I need. Okay. So we have fprintf. Okay. fprintf. And as you can see now, we have the logging coming out automatically of our client. So if we use the same client and we create a new request, let's say that now we have this, and we just copy paste everything. We copy and we go here, and then we add another request. Obviously we need to use this already, so we need to remove this stuff. So we get logging for each of those requests for free automatically, because the RoundTripper is used for the same client, and the client is used for the same request. So for each request that it's created from this HTTP client, we're gonna get the RoundTripper for free. Okay, so this is that's it. So the RoundTripper, the logger, it's as simple as you see here. It's very intuitive and very easy. Now we go to the retrying RoundTripper. So let's say that you do a request, you make a request, and let's say that this request returns 500 as a status code. And you want to retry the request that return 500. So we need to create a new RoundTripper that has a custom logic. So you have to think as the RoundTripper as a middleware. It's effectively a middleware that sits in between your request and your response, basically. And now we can just create a new one. So retry RoundTripper, which is a struct, and use the default RoundTripper as well, http RoundTripper, and max retries. We want to know how many retries, we want to specify how many retries we want to attempt, and then delay, it is a time.duration, for example, duration, which is delay between each retry. Okay, so, and then we go down the route of doing the same thing. Retry RoundTripper, and then RoundTrip, HTTP request, and HTTP response and error. So we have the default RoundTripper .RoundTrip using the request. So this is the same thing. So we just have to add logic here, right? So we just have to before we send the request out. Actually, the logic on this case is we send the request out to the next RoundTripper, and then once we get the response, we check whether the response is what we want. If it isn't what we want, then we retry the request again until it is what we want, or until we reach the max retries, which we defined here, right? So the first thing we can do is basically so we go in a for loop, and we take this inside the for loop. So we take this inside the for loop. We have the response, the error, and then we need to count the attempts. So we have the attempts, it's an integer. So once we have done the first request, we have done an attempt, and then if attempts is equal to max retries, that means that doesn't matter what we got as a response, we just return, and then I guess that we have to check you know, here for example, you know, the implementation, this one is implementation detail, so it's something that you will need to check yourself, so it depends you in which occasion you want to retry. In this case, what we want to do, we basically know that we first check that the attempts, we are not exceeding the max retries. So let's say that we are just one max retry, including the first attempt. We execute the first request, we have one attempt, the one attempt is equal to the one which is max retries, and we return, and so on, and it increments, and you know, that is, you know, our safeguard for, you know, whenever we have too many retries, so that allows us to exit the for loop. And then, you know, if we, you know, if we didn't arrive to the max retry, so let's say max retries is 3 and we have the first attempt, so this block doesn't execute, but we still need to retry if the request is successful in our case. So we just want to say that if the error is nil and if the response of status code is less than, for example, status internal server error, then we can return anyways, because it's a good case. This is you know, good outcome. Here is max retries exceeded, and then here we will need to basically delay and a retry. So one of the things you need to bear in mind, one of the things that you have to bear in mind is that you have a request context which can be cancelled. So you know, if this is somewhere else outside this function, you have we stop for a second. If somewhere else outside this function you have you have injected the context into your request. For example, here up in the request, you can create a new request with context. It's something that we have seen in a number of our previous episodes. You can inject a context with a timeout from the beginning here, or you can inject a context that is cancelled upon certain events. For example, it's cancelled when you send a signal to the terminal, when you terminate the program, or is cancelled you know, whenever certain operation occurs. So you still need to watch out for the context before you retry your request. So here it is what we do. We basically, if the context is cancelled, in this case we don't want to retry the request again. We just return the response, and then we return the context and the error of the context. This is just a safeguard in case you know, in case we have another context, a parent context for the request that has been cancelled, and we need to make sure that we don't leak resources. We don't you know, we don't spawn another request when the parent context has requested the cancellation throughout the tree of the context. So you can go check another video that I've done about context, and it's very interesting because it's used as well for request and timeouts. And so yeah, so if obviously the select is blocking, it's blocking until either of one of these two operations it's true. So either if there is a context cancellation, then you know, it returns, or in the second case it's just timed after, so we just need to sleep for a certain duration. So it is r.delay. So in this case it's just a time.duration. Yeah, so let's say that the delay is going to be 1 second. So then the first request is executed. Let's say that you have 2 max retries. The attempts is equal to 1. Attempts is not equal to 2, which is max retries. Let's say that the outcome is negative. So let's say that you get 500. The error is not nil, or even if the error is nil, the request, the response status code is going to be equal to status internal server error. So this good outcome doesn't get through. And then we select, so we block until either of these two cases, one of these two cases is true. So let's say that you don't have any context cancellation going, and automatically after, we said 1 second delay, so automatically after 1 second, the case unblocks, the select unblocks, the case goes here, and we start again for the for loop. In this case, we go to the second attempt. It doesn't matter what response we get. The second attempt is 2 attempts is equal to 2, which is the max retries, and we return the result. So this is how the the retryer RoundTripper works. And let's go through it, and let's actually put it here. So just commenting this one, and then we just gonna transport, and then we have the retry RoundTripper, and then default RoundTripper, which is http default transport, and then we said that we have max retries 3 and delay, which is time dot duration, which is gonna be 1 second. Let's see what happens. And I think we also need to import some stuff. See if there is no issues or something. Okay, that's 200. Yep. So I think that is okay, we just don't have visibility of what's going on because we lost the logger. And obviously here we are doing 2 requests. We just need to do 1 for now, just commenting. Actually, better to comment the second one, so we understand what's going on. Okay, just commenting this. And here we need to set the status to 500, status 500. Okay. So the retry RoundTripper, retrying 3 times. And max retries is 3. If error is nil, or if the status code is less than the status internal server error, or we just sleep and we retry again. Just looking what waiting. Yep. So we just get 3 requests. It's just so we don't actually see what's going on because we lost the logger. I was just confused by that. We lost the logger that we just created before, and there is a simple way that we can restore the logger again. So we can restore the logger without having to change anything here. So we'll leave as we have done. And the only thing that we change, is that the default RoundTripper, instead of being the default RoundTripper from the HTTP library, is going to be the logging RoundTripper. Right. So, and then here is the default. So obviously, that's why before I call it next, because it is effectively a chain of RoundTrippers, one after the other. And that's how I refer to Go as an orthogonal language, as a language that can, a lot of things that can be composed together and chained together. And this is a perfect example of that. So I'll just change this to be next RoundTripper. So obviously, login RoundTripper, It's going to have the HTTP default transport, and it's going to have the logger as standard output. We remove this stuff, and the default RoundTripper just want to change default RoundTripper to next globally. I think it did the trick. Yeah, I think it's import again. So now we have the retry RoundTripper. The retry RoundTripper has another nested RoundTripper, which is the login one. So each time we attempt a request, the login RoundTripper gets invoked and logs the request. So you know, if you think of it as a middleware, you always have the login one at the end of the chain, so it always logs all the requests. So let's see if it works. Okay. So as you can see here, we have 3 requests, and all are being logged and all are being retried. And this is 2 of the examples that we just seen of the RoundTripper, and this is very elegant because you can just change the implementation of your HTTP client, and now magically all your requests that you make for using the same HTTP client, they will follow the same rules, they follow the same configuration, and that's a very effective way, an elegant way that you can create the HTTP clients. I think we can just add another one, which is the auth one. So let's say that you have an auth endpoint. So let's just see now. So we have basic auth, Bob, and password. So let's see what it returns. Should be 401. Okay. So let's say that you have your HTTP clients and it's to do a lot of authenticated requests, and you want to make sure that. So let's remove this as well. Let's make sure that you have this as well, so you can. I need to improve my Vim macros. So let's say that you have to use your client for authenticated requests, and you don't want to authenticate before each request, or you want to do it automatically. Let's say that you want to call this instead of C authored client or something, right? So now c.do will be c.do will become authored client.do or something. Yeah, something like that. Here we still have to change that. So it's basic auth, Bob, and password. Okay, so let's say that we want to have a client that has embedded in itself the authentication, and we can use exactly the same configuration, exactly the same pattern. So we just implemented, the RoundTripper for the retry, the RoundTripper for the logging, and now we can implement the RoundTripper for auth, and we are done. Auth RoundTripper struct, and here is next, which is going to be the next one, RoundTripper, and then we have username and password. User and password string, which is a string. And then we have the RoundTripper, which is auth RoundTripper round trip, which is HTTP request, and then you have HTTP response error. Okay. Next, round trip. So now we need to inject the basic code just before we execute the request. So for the retryer, we had to tweak and do some changes after we did the actual request, the round trip. Now we need to do it before. We need to set the auth headers before, and for the basic auth we have automatically set basic auth, I think. Where you have the user and the password, so that comes for free. Set basic auth, godoc http request set basic auth, I think, yes, okay. And then obviously now we need to add it here, so we need to basically auth RoundTripper. Next, it's going to be this one. And then we have our user Bob and password. So here for context, Bob is the username here, and password is a password here, which is coming directly from http.bin.org, which is just the mock API that you can generate responses very easily. So this will generate a response that requires basic auth where the username is Bob and the password is password pwd. So you can test it. So before we had the 401 and here for 500 because we didn't change it yet, but we would have gotten 401 and 401 because we are doing 2 requests. So now let's see what we get. So we get 200. We get authenticated through because we're getting the HTTP. We're getting already the authored client. We use the authored client for all the requests, and all the requests are coming through with the authentication in set basic auth. So it is indeed as simple as you can see. It is as simple as you can see. You just inject the RoundTripper into the transport of your client, and you basically have a middleware that where you can change the fields, and you can change the behavior of your request and response. And I think that's everything for today. If you have any other questions or anything you want to know about the RoundTripper, just let me know in the comments below. And we didn't have time to do all the different scenarios. You have a lot of different things that you can do with that. You can imagine that for each request you can do caching as well. So here you could do even more complicated stuff. You can do caching, but it takes a little bit more here to implement it, because obviously you have to implement a concurrency save cache in this struct whenever you save the request and the response. For caching, for headers manipulation, so if you want to prepend headers, append headers to the request before each request is sent for the client. If you have, for example, if you have a scenario where you send an http.Client somewhere in your functions and you want to mock your HTTP request, you can use the RoundTripper. You just create a fake RoundTripper. You send your HTTP client. You have your HTTP client in your function. So let's say that you have a function. It's a func, for example, do something, or I don't know, sir, or new repository. Very often, it happens that you have new repository or something, and then you have, HTTP client. This is your repository and blah blah blah. And let's say that you want to unit test the new repository, right? So and most of the times, you know, you have to either use the HTTP test package from the HTTP and you know, create the HTTP recorder and all of that, which you're going to explore in another episode as well. But you know, you can also create the RoundTripper, a fake RoundTripper you can test. You can inject an HTTP client where you have a RoundTripper that returns always the same response, because you can return whatever you want. So there are a lot of different things that you can do with the RoundTripper, and I hope that today you have learned something about it. And thanks for watching. I hope you liked the video. Thank you.